beautiful studios of Way Happy. This is Mr. Meyer, and we are talking about how do you graph a rotated conic. Now, I said we'd do it in class, but COVID-19 has canceled that. So let's go ahead and now do it ourselves. So if I see this equation, this example right here, first thing I might want to know is what kind of conic is it? I wonder, and how can I tell? I can use the test, right? I can use the discriminant test, which tells me this is A, this is B, this is C. There is no D, there is no E, and there is an F. So there it is, right? Now the discriminant test is B squared minus 4AC. So in this case, that would be 6 root 3 negative squared minus 4. A is 7 and C is 13. So let's see, that would be 36 times 3. So negative 6 squared is 36 times 3. So that's 36 times 3 is 90, 108. 108 minus whatever 4 times 7 times 13 is. Now, 4 times 7 is 280 times 13. 28 times 10 would be 280. So this is definitely going to be a negative number, right? This is bigger than 280. I know that already. So 108 minus something really big is going to be negative. So what does that mean? That means it's less than 0, right? Or an ellipse. So I know it's an ellipse. So I'm like, sweet, looks like a little TIE fighter. So I know it's an ellipse. Now let's find out what the angle of rotation is. So, and the way that's found is the cotangent of 2 alpha, we'll call it, is equal to A minus C over B. So for us, that is A, 7, minus C, which is negative 13, over B, which is negative 6 root 3, or negative 6 over negative 6 root 3, which is 1 over root 3. So who has a cotangent of 1 over root 3? Well, let me think. Cotangent is the reciprocal of tan, sine over cosine. Okay, so using the hand trick, which you unfortunately cannot see, cotangent would be 60 degrees. So just looking at this, I know that this has to be 60 degrees. So that means 2 alpha has to be 60 degrees, or alpha has to be a 30-degree rotation. And you'll notice a lot of times it's either it's 30, 60, or 45, right? So the hand trick will work. So after all that, I know the angle of rotation is 30 degrees. And now, a lot of work for one problem, right? Now the fun. We know that if our original equation was x and y, so if I know that this is our x-axis and our y-axis, they are now rotated 30 degrees. So about 30 degrees goes like this, right? So if I kind of go like this, nice straight line, that we'll call x prime because this is 30 degrees. And this we will call y prime because that's, oh my goodness. This we'll call y prime because that's, again, about 30-degree rotation. And we know how to build our equation of an ellipse off of that. So I wish I had an equation that would make some sense. Well, I do, right? So going back up here, I can say, all right, our a prime for our equation will be whatever a is times the cosine squared of the angle. So a is 7 times cosine of 30 degrees. So 30 degrees cosine is root 3 over 2. But I have to square, well, I'll put it in root 3 over 2, but that's going to get squared, plus b, which is negative 6 root 3. So can I write minus 6 root 3 times the cosine, which is root 3 over 2, times the sine, which is 1/2, and then plus c, which is 13, and then times the sine squared, so a half squared. And that is our new a value. How gorgeous is that? What is that? That's 7 times 3 over 2, so 3 over 4, I heard you, minus, what is that, 18, so 6 times root 3 times root 3, that's 3 times 6, which is 18 over 4, because 2 times 2 is 4. And this one would be 13, so plus 13 over 4, which to me looks like 21 over 4 minus 18 over 4 plus 13 over 4 equals 21 minus 18 is 3. So 16 over 4 or 4. So A prime is 4. What about B prime? And what do you know about B prime? There should be something special. If our angle of rotation is correct, B prime better be 0. Otherwise, we need to do some new work. Minus 6 root 3 according to the formula. Cosine of the double angle. So if it's 30 degrees, I got to do 60 degrees. Cosine is a half. So where's that? Times a half, right? Plus C minus A. C is 13 minus A, which is 7, times the sine of the double angle, which is root 3 over 2. And you might notice that that is 6 root 3 over 2 plus 6 root 3 over 2. And that does equal 0. So at least I know. Good news. My angle of rotation is correct. All right, what about C prime? I will do that in a different color. C prime is going to follow the formula. Go get C, which I believe is 13. Yep, 13. And multiply that by the cosine of the angle. So again, it was 30 degrees. Cosine is root 3 over 2. So root 3 over 2 squared minus B, which is minus, or in this case, plus 6 root 3 times the cosine and the sine, root 3 over 2 times a half. And then plus A, which was 7, times the sine squared, which is a half squared. And so let's clean that up a little bit. That is going to be 13 times 3/4 plus, again, 18 or 18 over 4 plus 7 over 4. So that 39 over 4, I see, plus, now 18 and 7 is 25 over 4. So what is that? It's 50, 64 over 4. Oh my gosh, that goes in nice. Also, that would cut them in both in half, would be 32 over 2. Cut those in half would be 16. And so there's our C value is 16. So we got our A prime, B prime is 0, C. Now we have to find D. Well, the good news is D and E were both 0. So when I use the formula for D prime, I'm going to have 0 plus 0 because D and E in the original equation were zeros. Same thing with E prime. D and E are 0, so those drop out. And F prime is just F, so it's 16. So what does our new rotated equation look like? It looks like this. It looks like 4x prime squared, wanted to make sure, 4x prime squared equals 0. 4x prime squared plus 16y prime squared. And then our F was minus 16 equals 0. That is our new equation. Now that one's easy to graph, right? 4x prime squared plus 16y prime squared equals 16. Now remember, ellipses are supposed to be equal to 1. So I'm going to divide everybody by 16 and get x prime squared over 4 plus y prime squared over 1 equals 1. And now I am ready to graph. In the x direction, I will go 2 units. So good catch. In the x prime direction, I will go 2 units. In the y prime direction, I will go 1 unit. And there is my ellipse. Nice work. Stay happy, stay healthy, and we'll see you tomorrow.